Okay, guys, so today we're going to be looking at problem number 2 from Leetcode. It's called Add Two Numbers. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order. Each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except for the number 0 itself. Okay, let's take a look. So we got the number 243. I'm guessing that is 342, right? And then 564, I'm guessing that's 465. We'd be adding these two, we get 7. We add these two, we get 10. We have a carry. So that's 7 plus 1, which we carried over, and we get 8. So that should be 807. Okay, got it. So input here is, okay, so it's a list. It's represented as a list in Python. Okay, got it. And then 0, 0, okay, that's, this is an interesting one, right? So this is 9 plus 9, 18 carries, 9 plus 9, 19, because we have a, one of carry. One carry, 9 plus 9, 18 plus 1 carry, 9, and so on. And then that 1 carry goes all the way forward. Okay, got it. So a couple ways that I can think of solving this problem. One is we can cheat. And by cheating, I mean we can simply concatenate all of the numbers within this optional linked list node and just do Python addition and then convert them back to a linked list. I mean, I guess that would be fair game, and that should be fairly easy to write. Unfortunately, I don't think that that's something that if you're in actual, interview, folks would be okay with. So the other way is, well, we can simply solve the problem I'm guessing as is supposed to be, which we can simply add the, two nodes and then follow on and have a carry, right? And that should be fairly straightforward. So why don't we start with some kind of base case, right? And the base case that I can think of here is if any one of these is none, right? Given that these are optionals, or even if they are zeros, we can simply just return the other one, right? So why don't we start with that? So if not L1, okay, L1, then we can simply return L2. If not L2, we can simply return L1, right? Perfect. So then we're going to need somewhere to store this result, right? And this result has to be a linked list, right? I'm looking at this type annotation. It is an optional linked list. So why don't we create that? So I'm guessing we will need this list node. So list node. Okay, so we can take the empty constructor. That's a 0 with the next of none. Now, let's see. We're going to need to maintain two things, right? I'm thinking of one is going to be the carry, whatever we're carrying over from the current two nodes that we're adding to the next one, and where we are within this result. Because if we move this result pointer, then we're going to have to somehow rewind it back to the beginning of the list, which is going to be really hard. So I think it's much easier for us to just keep a second pointer into the list, which is kind of like where we currently are. So how would that look? So there would be something like carry, current, 0, and well, our current pointer will just start at results, right? Okay, so now let's think. So now we're going to have to iterate both pointers from L1 and L2 at the same time, right? And as we're iterating between those two, we're going to have to be adding the numbers and having this carry, right? So how would that look? So something like while L1 not equals to none and L2 not equals to none, what we're going to have is, well, let's figure out the sum, right? So the current sum, that's just going to be L1.val plus L2.val and my carry, right? Because even though at the first iteration, I will not have a carry, at the next iteration, I may have a carry, right? So let's figure that out. And then we're going to have to figure out what is my next carry and what item, what value should I be storing at that particular node, right? So current.val, so that's the current node, the value of the current node that we're looking at. And my carry, well, the value of my current node is simply going to be, so let's take an example of 9 plus 9, right? So in this case here, our so our current sum would be 18, right? So what we want to store in current val is going to be 18 modulo 10, right? So that's going to be current sum mod 10, right? So current sum mod 10. Now my carry is basically going to be, so in this case, of adding 9 plus 9, where we get 18, it would be 1, right? So we simply want to divide that by 10, right? So current sum, and I'll do an integer division by 10 so that we don't have any kind of floating point numbers, right? Okay, so now what do we need to do? Now we need to, well, two things. First, advance this L1 and L2 pointers. And second, we probably need to create this next node within this current node list, right? So yeah, when do we start with that? When do we start with creating the next node and then we advance the pointer? So what would that look like? So basically, if L1.next not equals to none, right? Meaning if we have a next value within L1, or if L2.next not equals to none. So this means if there is a next value for us to look at, we will need to create a new node within our linked list. So let's do that. So current.next is equal to list node. So this is creating the next node within the linked list, which is storing our results. We need to advance this current pointer as well, right? So current is equal to current.next, right? So this is advancing that current pointer one step forward. Now, finally, let's advance the 2 pointers from our L1 and L2 linked list, right? So this will be L1, L2 equal L1 dot next and L2 dot next. Okay, so that's very easy. Now we get after we've looked into the common. So this would work for this case, right? But this shouldn't work for a case like this, and we can actually run and check that. So we have to return results, and if we run, we're going to be able to see it should pass this case, but I doubt that it would pass this case here. Oops, I got a typo here. Right, and that's because in this case, example 3, yep, as you can see, example 3 fails because L1 is bigger than L2. Now, if L1 is bigger than L2, or if L2 is bigger than 1, then we're going to need to continue looking into the L1 or L2 list, whichever list is bigger, to continue adding those values and continue following the carry to our results, right? So if we don't do that, we're going to get this, right? We're going to get an incomplete result. So how do we do that? Essentially, what I'm thinking is we can do the exact same thing as we did here for both, right? Exact same thing. So let's just copy and paste. When we start with L1, so this will be L1 not equals to none, L1 value, current sum, okay, that looks good. And here, there's no L2, right? So I think we're good to go. And there's no L2 here as well, right? And now we can do the exact same thing for L2, right? So instead of L1, in this case, it's just L2. And in this case, it's just L2. And yeah, same thing here, right? We need to only advance if L2 is none. And the pointer that we'll be advancing is the L2 pointer. Now, here we're still going to miss a case. If I run, in this case, 3 should still fail. In this case, we would get 8999000. We'll be missing the 1. Let's see if that's true. 8999000. We'll be missing the 1. Let's see if that's true. 8999000. We'll be missing the 1. Let's see if that's true. 8999000. We'll be missing the 1. Let's see if that's true. 8999000. We'll be missing the 1. Let's see if that's true. And that's because, yep, so that's true, right? So that's because we are missing if we need to check if there's a carry. If after all of these loops we have a carry, well, guess what? We need to add that carry to the end of our result list. So how do we do that? If carry not equals to 0, then current dot next is going to be list node of the carry. All right, so this should work. Let's take a look. Let's run. Okay, all three cases look good. Let's submit. Let's see if it passes every other case. Yep, looks like it does. All right, guys, thank you for watching.